Hello students, welcome back to our class. So, in this session we are going to discuss about what is the importance of sum to n terms of arithmetic progression. So, in the previous session we discussed about nth term of an arithmetic progression would be of the form Pn plus q, it means a linear expression. Like that, what can you infer about sum to n terms of arithmetic progression? Hope you understand. What is sum to n terms of arithmetic progression? Sn is equal to n by 2 times 2a plus n minus 1 into d. We can write this as n by 2 into 2a is n by 2 into 2a plus n by 2 into n minus 1 into d. So, n by 2 into 2a is going to be 2 cancel, that is going to be an, plus here n by 2 into n minus 1 into d, n into n is equal to n square minus n into 1 equal to n into d by 2. So, we can write this as an plus n square into d by 2 is d by 2 n square minus n into d by 2 is d by 2 into n. If you group them, then we get first d by 2 into n square, because n square term is that. So, d by 2 into n square, an minus d by 2 n, if you take one n common, then it would be a minus d by 2 into n. This is what? Sum to n terms of an arithmetic progression. So, what can you say about sum to n terms of arithmetic progression? This is in which form? See, something into n square plus something into n. N square term is there, n term is there. Can we call it as a quadratic expression, a second degree expression? Absolutely, you can call it as a quadratic expression or second degree expression, but ensure that there is no constant. But in second degree expressions or quadratic expressions, you will have a constant, right, which is in the form of ax square plus bx plus c should be there. But here the value of c is going to be 0. So, that you can say sum to n terms of an arithmetic progression would be a second degree expression without a constant, second degree expression without a constant. So, you can write it as something into n square plus something into n, right. Now, let us compare both of them. What are those somethings? When you compare both of them, like first compare n square terms. So, when you compare n square terms, then here n square term is d by 2 times n square, and here n square term is p into n square, right. So, d by 2 into n square equal to p into n square, it means d by 2 is equal to p. What is d here? D is the common difference. Therefore, from this you can say that d is equal to 2 into p. What is that p there? P is going to be coefficient of n square. Then common difference would be twice the coefficient of n square. Common difference would be twice the coefficient of n square. Then I will give you one example and we will discuss about sum to n terms of arithmetic progression. See, sum to n terms of arithmetic progression is in the form of Pn square plus Qn. It means it is a second degree expression without a constant. So, Sn is equal to 2n square minus 5n, correct. Is it in second degree form without a constant? Absolutely. So, which is in the form of Pn square plus Qn. Then what is the value of P and what is the value of Q there? P is equal to 2 and Q is equal to, what is the value of Q there? Q is equal to negative 5. What is the common difference of this arithmetic progression? Common difference is equal to d, which is equal to twice the coefficient of n square, twice the coefficient of n square, which is going to be twice the coefficient of n square. P is equal to 2, right. So, 2 into 2 is equal to 4. So, this way easily you can figure out what is the common difference of the arithmetic progression when sum to n terms of arithmetic progression is given. This is not nth term, this is sum to n terms of arithmetic progression. Okay. So, let us discuss about a few set of examples on this sum to n terms of arithmetic progression, especially when this 2n square minus 5n kind of expressions are given. Okay. Right. So, the very first example is going to be check whether Sn is equal to n square minus 4n forms an arithmetic progression. Check whether n square minus 4n forms an arithmetic progression. Right? If so, find its common difference and nth term. Okay, this is the problem given. First of all, check whether Sn is equal to n square minus 4n forms an arithmetic progression or not. So, to check whether it forms an arithmetic progression or not, you need to find what are the terms of this arithmetic progression. When an is given, then we can easily form what are the terms of arithmetic progression by putting n is equal to 1, n is equal to 2, n is equal to 3 and so on. But here it is not an, it is Sn. So, to check whether it forms an arithmetic progression or not, first thing that you need to find out 3 terms of this arithmetic progression by using Sn. So, how is that possible to find out 3 terms of arithmetic progression? For that, what do you mean by sum to n terms? Sum to n terms means when you have n terms and when you keep adding all these n terms, then you get sum to n terms. It means first term plus second term plus third term plus so on plus n terms. This is what is called sum to n terms. Suppose if I have only 3 terms, then I can write S3 is equal to A1 plus A2 plus A3. Suppose I have only 3 terms, then I am adding all those 3 terms, then I am getting sum to 3 terms. Suppose if I have only 2 terms, then it would be A1 plus A2. Suppose if I have only one term, then S1 is equal to A1, right. Now, I got an idea to get what is first term. Okay. So, since the value of Sn is going to be n square minus 4n, when I substitute n is equal to 1, then I will get S1. S1 is equal to 1 square minus 4 into 1. So, 1 minus 4, what is 1 minus 4 is equal to negative 3. According to the discussion, S1 is equal to A1, right. Therefore, A1 is equal to negative 3. I got what is the first term. Now, I need to get what is the second term as well as what is the third term also. So, to get second term, I will go for this. What is that? S2 is equal to A1 plus A2 and S2 is equal to A1 plus A2. Again, S2 means substitute 2 in the place of 2 in the place of n. 2 square minus 4 into 2, 2 square minus 4 into 2 is equal to A1 plus A2. A1 is equal to minus 3 plus A2 I do not know. So, A2 is A2 only. 2 square is equal to 4 minus 4 2s are 8 minus 3 would be plus 3 is equal to A2, correct. So, 4 minus 8 is equal to, otherwise 4 plus 3 is equal to 7, 7 minus 8 is equal to minus 1. Therefore, I would say that second term is equal to minus 1, correct. So, I got first term and second term, but I need third term also to check whether it forms an arithmetic progression or not. Then I will go for this. So, can I write this S3 as S3 is equal to A1 plus A2 is equal to, can I write it as S2 plus A3, or else you can directly, because already the values of A1, A2, A3 are all there. So, that is why you can substitute them. Okay. So, S3 is equal to A1 plus A2 plus A3, A1 plus A2 plus A3. So, S3 means substitute 3 in the place of n. So, it would be 3 square minus 4 into 3 is equal to A1 plus A2. A1 is equal to, what is A1? A1 equal to minus 3 plus A2, A2 is equal to minus 1 plus A3, that is what we are finding. 3 square equal to 9 minus 4 2s are 8 minus 3 minus 1 is minus 4. So, plus 4 is equal to A3. See here 9 minus 8 equal to 1 plus 4 is equal to 5. Therefore, the value of A3 is equal to 5. After finding A1, A2, A3, let me check whether the common difference is same or not. Okay. First I will find a2 minus a1. a2 is equal to minus 1 minus a1 is equal to minus 3. So, minus 3. What is this value is going to be? Minus 1 plus, because minus of minus plus 3. What is minus 1 plus 3? Equal to 2. So, the value of a2 minus a1 equal to 2. Fine. I will find what is a3 minus a2. So, a3 minus a2 is going to be, a3 is 5 minus a2. a2 is equal to 1, right. So, here did I find the values of a1, a2, a3, correct. So, a1 is equal to minus 3, a3 minus a2. So, a3 minus a2 is minus of minus 1 is going to be plus 1, 5 plus 1 is equal to 6. So, getting different answer. a2 minus a1 is minus 1 plus 3 is equal to 2. So, let me just check once again. Sn is equal to n square minus 4n, n square minus 4n, when you put n is equal to 1, then I will get 1 square minus 4 into 1 is equal to 1 minus 4 equal to minus 3, and S2 is equal to a1 plus a2, when I put 2 here, 2 square minus 4 into 2 is equal to minus 3 plus a2, 4 minus 4 2s are 8 plus 3. So, 4 plus 3 is equal to 7 minus 8 equal to minus 1. So, a2 is equal to minus 1. S3 is equal to a1 plus a2 plus a3. S3 means 3 square minus 4 into 3. 3 square minus 4 3s are 12. Yes, I did a small error here. That error is going to be 4 into 3 is equal to 12, right. So, here it is 12. Then when I substitute 12 over there, then what am I going to get here? I am going to get 9 minus 12 plus 4. So, 9 plus 4 is equal to 13, 13 minus 12 is equal to 1, right. That is the value of a3. Now, a3 minus a2, a3 is equal to 1 minus a2 is going to be minus 1. So, 1 minus of minus 1 is equal to 1 plus 1, that is 2. Therefore, a2 minus a1 is 2 and a3 minus a2 is also equal to 2. So, what can you say about this? Therefore, a2 minus a1 is same as a3 minus a2. It means this Sn is equal to n square minus 4n forms an arithmetic progression. Since it forms an arithmetic progression, we can find what is the common difference as well as nth term of arithmetic progression also. See what is the common difference, we can easily identify what is the common difference here. 2 and 2, it means 2 is the common difference. In fact, without doing all these things, we could answer this problem easily as like the concept we discussed earlier. That is what? Nth term, sum to n terms of an arithmetic progression would be second degree expression without a constant. This is a second degree expression without a constant. And what is common difference? Common difference would be the coefficient of n, twice the coefficient of n square. Coefficient of n square is equal to 1 here. So, twice the coefficient of n square means 2 times 1, 2 times 1 is equal to 2, 2 is the common difference. So, with the help of this, you can easily find out what is the nth term of arithmetic progression by taking a as well as common difference. Therefore, nth term is going to be a plus n minus 1 into d, correct. A is equal to a1. What is a1 here? A1 we got it as minus 3 plus n minus 1 into common difference is going to be 2. So, when you simplify this, minus 3 plus 2 into n is equal to 2n minus 2. So, 2n minus 3 minus 2 is equal to 2n minus 5. So, this would be the nth term of arithmetic progression. Understand, this is what the importance of sum to n terms of an arithmetic progression. So, it is very easy and very important in our examination point of view as well as in competitive examinations also. When you are given sum to n terms, the very first thing is you need to check whether it forms an arithmetic progression or not. Every Sn may not be the Sn of arithmetic progression. Hope you understand. Every Sn may not be the Sn of AP, or every Tn or every An is may not be the nth term of arithmetic progression. So, sum to n terms of arithmetic progression will always be a second degree expression without a constant. And when it is an arithmetic progression, it is sum to n terms of an arithmetic progression, then the common difference would be calculated easily just by taking the coefficient of n square multiplied by 2. So, twice the coefficient of n square would be the common difference when sum to n terms of an arithmetic progression is given, and when nth term of arithmetic progression is given, then you can say that common difference would be the coefficient of n, and it is a linear expression, would be the nth term of arithmetic progression. So, hope you understand. Thank you.